So you have the note sheet, you don't have to write as much. What our big focus today is when you're asked to give the percent and you're given two quantities, all right? First of all, this is a typo in here. I should have fixed it. You should say as a percentage. First thing you do when your class leaves. Okay, so change that. To express one quantity as a percent of another quantity, B, we follow the following steps. Here's one quantity A as a percent of another quantity B. We write A. Oh, another typo again.
Right as 20. I think that
Okay.
should go after the last.
Oh, okay.
You know, you put the 8 over
There we
the
go.
other
All
side.
right. So, what should this be, please? Correct. A as a fraction of B. So if we want to find A as a percent of B, the first thing we should do is write A as a fraction of B. The fraction right here would be what over what, Ethan?
A over B.
A over B. Very good. Once we have a fraction written, then we need to convert it to a percent. A lot of you got the question right that asked, what does percent mean? Percent means parts out of 100 or hundredths. So, one way we can convert our fraction to a percent is to use equivalent fractions to the denominator of, Mason?
The percentage
Out of 100. So we take A over B, and if we can change it to a fraction of something over 100, we know what our percent is. Sometimes that doesn't work, though. Sometimes we're dealing with something like 5/7. And you can't, no matter how hard you try, change that to something over 100 easily. So we say when the denominator is not blank to 100. It's not really a mathematical word. Margaret? Not equal, because even if it's not equal to 100, like fifths or 25ths, we can change it to hundredths. But when the denominator is not, starts with that. It's not a mathematical word.
Fraction.
Friendly.
Oh.
When it's not friendly to 100, what do? And lots of you remembered this on the fraction, on the percent pretest. What do we do when it's not friendly to 100, Jack? Divide. And change the resulting decimal to a percent, knowing that percent is hundredths. All right, moving on. Bubba earned 108 out of 150 points on his history test. What percent did he earn? It's asking you for the percent, so you should say, I should write a
Fraction.
Fraction.
Next time, let's say that louder. It's asking for a percent, so I should write a
Fraction.
Now, what's the fraction component? Good. Percent out of 100, though, and I'm out of 150, so can I change this to hundredths easily? That would be my first choice. Even?
No, but you can change it to 50, yes.
Okay, which is nice.
And then you can multiply that by 2.
Great, so what is it when I change it to 50 of Ethan?
It's 36 over 50.
36 over 50, I'm a factor of 3. Mason?
And you multiply that too.
And you did?
72.
Out of 100, which means Bubba earned what, guess?
72%.
72%. All right. So that's a friendly one. All right. Example 2. Different way of wording it. Express the first quantity as a percentage of the second quantity. Remember, friendly reminder that this of is the key word that the denominator or the whole follows. And we always put that in the denominator. So in this case, we're expressing the first quantity as a percent of the second quantity. The second quantity is the base quantity and goes in the denominator. What's the first thing we got to address in letter A here? Callie?
You gotta, have the same units.
Yeah, just like with ratios. So,
Milliliters. So it'll be 174 over 2,000.
yes, 2 liters is equal to 2,000 milliliters. So we got 174 over 2,000. What do you recommend for me to do now? We're trying to get hundredths for a percent. Alex?
You could divide it by
What's the first step? Divide by 2. Let's get it to thousands. 174 divided by 2, Mason?
87 over 1,000.
87 over 1,000. But percent is out of what, Lena? 100. So what component?
She got 8.7%.
Divide them both by 10, and you're right. It's 8.7 over 100, which means 8.7%. Don't fear the decimals. You will see them a lot. That's kind of one of the main differences, is that your brains are better able to deal with that now than they were before. Questions?
Is this another repeat?
Alright. Next one. We're still expressing the first quantity as a percentage of the second quantity. So in part B, Julian, got to write a percent, which means I'm going to write a
Fraction!
Good. What fraction, Julian? First quantity as a percentage of the second.
45 over 36.
Ah, 45 over 36. Guess, what kind of fraction is that? Well, it appears unfriendly at first. What else is
It's
it?
improper.
Improper. Which means what as my percent? What do I already know as my percent that I'm going to arrive at here? Lena? Yeah, we're talking over 100. Right. What can I do to this to decide if it's friendly or not? Mahoney?
We multiply it by 3.
Okay.
Yeah, 15. And then you 15 by whatever, yeah, what? 15. Yeah. That's 12.
That's 12. Oh, Connor. Is there another factor? What could we go further to? 5 and 4.
20 times 20, 80.
Not times 20, we want hundredths.
25. 125%.
Oh, yeah.
What percent are we talking here, Mason? Yep. Don't be afraid of percent over 100 or under 1. You'll see a lot more of it now. Questions? All right. What percent of 96 is 42? Just in words now. Oh, it's asking me for a percent. I should write a.
Fraction.
What is my fraction? What is my base quantity? What's my whole? What goes in the denominator? Margaret? How did you know it's 42 over 96, Margaret? What was your thought process? All of 96 tells me my base quantity. It goes in the denominator. Very good. All right. What can I do with this one? Kelly?
You can divide it by 3. So you'll get 50, no,
14
yeah,
over.
over 32.
Anything
Not.
else? Please? I get 7 over 16. And that is what, Ethan?
Well,
Is it friendly?
no, it's not.
It's unfriendly.
Can you
What do you do?
do, can you divide it again by like 4? You just have a decimal there?
I don't wanna get into that. You can, in this particular example, and you're gonna get the right answer. But the other strategy we can always rely on is to do what? Divide. What division problem, please?
Oh, 7 divided by 16.
Good, which means 7 goes in the box, 16 goes out here.
Mrs. Stanton,
Yes?
didn't you just do 7 over 16 times 100 over 9?
I'm staying away from that strategy because kids mess that up and use this apply it in other situations. So this is the strategy that I'm going to focus on. This is going to guarantee success for everyone.
Well, what if people can't do
You can. Yes. How many times is 16 going to 70, Connor? 10?
tries,
What's the big?
Alright, when these don't work out to whole numbers, we're going to divide until we can round to the nearest whole percent. We're not going to go forever. Alright, 16 goes into 60 how many times, Jack?
3.
3.
Doesn't it eventually work out?
It does, but we're not going to go until it works out in this case. 16 goes into 20. Alec? Once. That is far enough because percents are hundredths. And I've got 43 hundredths right now, 0.1. What is that when I round it to the...
Isn't it 12? 60 minus 48.
Oh, yes. You're right, actually. It's not 1. How many times is 16 going to 120?
7.
7. 7. 7 times 6 is 42. Carry the 4. Oh, yes. Very good. Thank you. All right. So it's 4300.7. So what should I say this is approximately to the nearest whole percent? Margaret? 44%. So anytime you get one of these, go ahead and take this approach. Round to the nearest whole percent. Don't go further than that.
Can you do a squeeze?
Because it's approximately. It's not exactly equal to it. And there will be times where I'll give you problems where you just use the calculator and you follow the same procedure. You divide numerator, divide denominator, move the decimal point, and round. Okay. And another good reason to focus on this strategy primarily versus any other one is because in real life, when you're doing a strange percent, this is what you'll do. You'll get out your calculator. You'll divide and you move the decimal point. It's the easiest way to do it. Okay? Questions? All right, we're going to skip 4. Well, let's not skip it. Let's change it. Let's make it something different. Let's make it 54 is what percent of...
54.
of,
100.
how about we do...
36.
1.
Nope,
Hold
on.
108.
54 is what percent of...
100.
10.
50.
15.
50.
15.
No, let me think.
216. 24. 26. 270.
Oh,
569. 24. Those are all factors of 54. About 50.
Let's say,
270.
I don't want 81. Let's go, I don't want 27, that's too easy. So, let's see what happens when we do up 36.
What?
All right,
Oh,
What?
okay, let's do this. Is what percent, I'm trying to find the percent, I'm going to write a fraction. What's the fraction? What goes in the numerator and what goes in the denominator? Goes in the numerator and what goes in the denominator, yes?
54 over 36.
So what do I know about my percent already, Connor?
It's improper.
Which means my percent will be
Over 100.
very good. All right, now what should I do here? Yes, not yes, Tony.
you should really divide it by 4. I mean by 3.
Okay.
And you get 18. Over 12.
Can I go further?
Yes.
What do I get?
9 over 6. Oh.
I don't think.
Just
we
divide
just
by
divide
6.
three.
Now I can, but I'll divide
3,
by
2.
3.
This is the one I'm still.
Make sense?
It's 1.5. It's
Good. Okay. Again, don't be alarmed if your percent's over 100. That was really the point of that problem.